Good evening, friends. Yesterday we have seen what is visual angle and how to measure the visual angle. For just recap, we have this formula for visual angle. Visual angle theta is equal to 2 into tan inverse small d by capital 2D, where small d is the diameter of the object and capital D is the distance of the object from the observer. Now, in order to find this theta, you should have this logarithmic table and trigonometric table at your hand. If we can simplify this formula so that we can calculate this visual angle without the use of this trigonometric table, it would be easier. Na? Let us see whether it is possible. Now, we have one fundamental limit of calculus. Limit theta tends to 0, tan theta by theta is equal to 1. The meaning of this is, if the limit theta tends to 0, that means if the angle, visual angle in this case, is very small, then this tan theta by theta is approximately 1. That means this tan theta is almost equal to theta. This is the gist of this formula. Now let us see here. Theta is equal to 2 into tan inverse d by 2d. This implies theta by 2 is equal to tan inverse d by 2d. Now, by applying this limit here, we can understand one thing. Now, this further simplified as tan of theta by 2 is equal to d by 2d. Now, by applying this limit, tan theta by 2 is equal to d by 2d. This can also be written as theta by 2 is equal to d by 2d. Now, we can cancel out 2 on both sides. This implies theta is equal to small d by capital D. The meaning of this is that visual angle is simply equal to the ratio of the diameter of the object to the distance of the object from the observer, small d divided by capital D. This is the simple formula. Now let us take one example. I am having one object here. Let us say a ball. The diameter of this ball is 10 centimeters. Okay. Here is the observer. This is the distance of the object from the observer, and this is the angle theta. Now we have to measure this theta. Without applying this trigonometric formula, we can simply calculate this by the dividing this diameter by this distance d. Now let us see how to do this. I will say this distance from here to this, let us say this is 570 centimeters. Okay. Now this theta is equal to 10 divided by 570. Now I will tell you why I have chosen this particular value 570. This 570 is 57 times this 10. As you can see it easily, this is 57 times this 10. Now this 57 has some importance in trigonometry, because this 57 is the factor by which you have to multiply a radian to convert it into angles. 1 radian is equal to 57 degrees 17 minutes 44.80 seconds. This is the value of 1 radian. Now I am approximating this 1 radian to 57 degrees for the purpose of simplification. That's why I have considered this 57 as the multiplying factor. Here now this theta I am going to multiply by 57. 10 divided by 570 into 57. This gives 1. That means the visual angle of this object is, as seen from this observer, is 1 degree. This 1 degree is the visual angle of an object which looks 2 times as large as the sun or moon looks to our naked eye, because the sun or the moon is around 110 times further than their diameter. For example, here is the earth and here we have the moon. The diameter of the moon is 3476 kilometers, and from earth the distance of the moon is 384,400 kilometers. This 3476 divided by 384,400, this gives approximately 0.515 degrees. That means the visual angle of moon as seen from the earth is half a degree, and the same is true in case of the sun also. Here lies the earth and here is the sun. The diameter of the sun is 13,92,000 kilometers, and the distance from earth to sun is 15 crore kilometers. This is the distance from earth to sun, and this also approximate to around 0.52 degrees. That is why both the moon and the sun looks at the same size from our earth.